Well, this is it, folks. We're down to the last set of coils. The old power transformer. Someone asked me where I get my schematics from before I start. I thought I'd tell everybody. What I do is I go to Nostalgia Air, blow it up to 200%. Then I do a print screen. I press the print screen button and paste it into the paint program. Once I get it into the paint program, I can eliminate what I don't want and have an erase feature there. So, I'll eliminate all the blue crap that's on there that I picked up from the Nostalgia Air. Then we go ahead and I print it all out, and it comes out in like several pages because it's really big. Then I just cut and paste or tape it together with Scotch tape. And I make my markings on it. And I do that just so it makes it easier to show you what I'm doing. I don't usually do this just for working on a radio. But when you're dealing with videos, I want it to be big enough so everybody sees and everybody understands. This is called a teaching aid, and a visual aid. And visual aids should be good. They taught us one time, I was in an instructor school many years ago, they taught us, always use good visual aids, but if they turn out not to be so good, don't apologize for them. Okay, so that's where we're at. Okay, what are we doing here? Alright, we're going to check out the primary and the secondary. We're going to check out this primary winding right here. Remember, it's nothing. This is just a transformer, a much larger transformer, no different than the IF transformers we ohmed out. We had a left and a right side. This is the primary, this is the secondary. Now the way we ohm out the primary, this is just a capacitor to ground that comes in from one side of the power line connected to the on-off switch. What we're going to do is I'm going to take the multimeter and I'm going to hook it right here. And I'm going to hook it right here, down here, on those two lines right there. That would be the power cord. So let's turn this turn this radio around here. And we do have a stub of power cord there that we can use. Here it is right here. So I'm going to go ahead and strip back the wire a little bit on each of these, and then we'll connect up our multimeter and see what we get. Alright, we're ready to go. I've got one side of the power cord connected to the gator wire and connected to the multimeter lead. And again, I'm going to touch the two leads together to make sure my multimeter is working. And it is. See, I'm just touching it. Alright, multimeter is working. Now, all we have to do, remember, we're going to be testing through the switch, down through the coil, and out. I mean, there's just really nothing to that. That's what they call a no-brainer, okay? Okay, let me go ahead and touch this other wire down here, and you watch the meter. Hopefully we'll have a good primary. Look at there. Look at there. We have a good primary. Outstanding. Let's see what that thing's reading. It's reading about 23 ohms. According to the schematic, it's supposed to read about 15. It says 15 ohms right there. I'm pretty happy with that. Let's move on to the secondary. Now we've got to test this coil. This coil. We're going to just ohm across it, just like we did with the primary. We're going to test this one, and we're going to test down through here, and we're going to test from the ground. This is the center tap. Now let's say we had 1,000 ohms. This is just an example. Let's say we have 1,000 ohms. It's supposed to be 1,000 ohms. It reads 1,000. Actually, this one's supposed to read 700. There it is right there. But we'll just use round figures that we all understand. Let's say it has 1,000 ohms, and let's say it reads good. After that, I should be able to take my black multimeter lead, put it on ground, and touch it to here, or actually be pin 2 of the 80 tube. See it? I should get 500 on each side. 500 ohms on each side. From here to the bottom half here, and from here, ground, to the top half here. 500 equals 1,000. But in this case, it's supposed to be 700 ohms, so I should get around 350 on each side. Alright, let's set that up. One more thing before we go to the secondary I wanted to tell you. Now, again, this is for folks who have not done this or are not sure about it. It's not for the old timers that know all this stuff. Had I tested across these two wires and gotten no continuity, that does not mean that this coil is open. It could mean that the on-off switch is open. So you would have had to go to the front of the radio and turn the switch on, which would have closed that right there. Okay? Then you would have got your continuity through. But if the switch is closed and you get no continuity and you know you've got a good connection here and here across these two, well, you've got an open primary. Fortunately, we don't have one. Alright, let's start with the filament line coil off the secondary. You'll notice that one side of that coil comes across, goes down to pin 1 on the 80 rectifier tube. Then it goes through the tube and back out pin 4 and then up to the other side of the coil. So all we have to do is measure the rectifier tube socket between pin 1 and 4. If we get continuity, we know that this coil is good. I'm telling you, this stuff is so simple. I think I might try the next one with my eyes closed. Okay, here we go. Again, let me back up so it won't be so blurry here for you. Again, the two large holes are the key. In between the center, right here in the middle. Counterclockwise from the top. So that'd be 1, 2, 3, 4. So we need to go between pin 1 and 4. Well, we've already got one. I've already got this one in pin 1. So let me go and touch pin 4 and you can see what we get on our multimeter. Looky there. Looky there. Touch. Yes. Alright. I'm a happy camper. We now have two pieces of the puzzle solved. We know that this one's good. We now know that this one is good. Now we need to go down and test between pin 2 of the 80 rectifier, which will take us up, down, around, and over to pin 3. So if from pin 2 to 3 is good, it means the entire secondary is cool. So let's try that next. Let me get that set up. Alright, once again, it is pin 2 and pin 3. Now I've already got the black lead in pin 2, again going counterclockwise. It's 1, 2, this would be 3. So let me go ahead and stick this multimeter lead right here in pin 3. You watch the meter. There it goes. It goes up. It's not going up very far. The reason being, this is on the 1 scale. We're reading about 700 ohms, almost exactly what we're supposed to have. See, that says 700 right there. So I'll tell you what, let's take the meter up to R times 10. Let's see what that does. Got my multimeter lead hung up here on a wire. Get loose of here. Okay, here we go. Let's try it again. This time on R times 10, which would give us, we should have something around somewhere in this area. Let me see. Somewhere in that area right there. Let's see what happens. There it is right there. Look at that. 700 ohms right on the nose. I'm amazed. 700 ohms. Wow. Okay, we now have 700 ohms down through here. Our coil is good from here to there. Now we need to go from ground to pin 2, which will give me the top half, and ground to pin 3, which will give me the bottom half. I just want to make sure that they come up to about 350 on each side. So let's set that up. Alright, for this little ditty, I went ahead and hooked up my gator wire to the black lead on the multimeter, and we're just going to clip it on any place where there's a ground. That'll work. You don't like that? Alright, you can put it there where there's a ground. Still not happy? Yeah, what the heck. We'll just come over here and we'll clip it down here on this thing right here that's connected to the ground. I don't care. We can go anywhere. I'll tell you what, we'll just clip it on this one. What do you say? Okay? A ground is a ground is a ground. Alright. What we're looking for here now is black to pin 2, or ground to pin 2, and ground to pin 3. 2 and 3. Here we go. Here is, we're still on the 80 rectifier tube now. This is pin 1, pin 2. So let's see what happens. Touch. There it is. That's pin 2. That's good. Good, good, good. Runs about 360, which is about half. You know, my meter is not the most accurate meter in the world. Here we go again. Here's the other side. There's pin 3. There you go. Same thing. Same reading. Look at here. All right. This is getting better by the minute. This is good. This is good. This is good. Both halves are good and connected to ground. The only thing left is down here, and guess what that is? the filament line. It lights up the heaters, actually. The heaters. Provides the heater voltage. So let's get that set up for the very last reading. Let's go back to the small schematic for a minute. The very last tube in this chain is the 2A5 right here. Okay? And the 2A5 says, after I wrote the little tube pin numbers on there, that pin 1 and pin 6 is the heater. Pin 1 and pin 6. Alright, here's the 2A5, the way it looks blown up on the schematic down below. Down in this area right here where they have these little humps. Okay, I blew that part up. Pin 1 and pin 6 of the 2A5. If I stick my multimeter probe in pin 1 and 6 and I get a reading, it'll mean that this very last coil is good. Alright, pin 1 and 6. 1 and 6 are these two right here. These are the two large pins with the separation between. That's the key. So this is 1, 2, 3, 4, 5, 6. So we'll stick this one down in there and see if we can get a good contact to pin 6. And the other one to pin, no, I'm sorry, that's pin 6 is over there. What's the matter with you, John? Don't you know 1 from a 6? Okay, that's 1, 2, 3, 4, 5, 6, and then this one here is pin 1. Now when I stick that down in there, let's hope we get a reading. And we do. Look at that. Look at that. Okay, folks, you all know what that means. All the coils are good. And what it means is this radio can be repaired. This radio will play. Unless something drastic happens to it, like it gets hit by lightning or something, this radio will play. All the capacitors, all the resistors, anything else I need for it are available. Piece of cake, trust me. But there's one other thing I wanted to show you. Now, this is primarily for the new folks again. Suppose I had taken my reading through here and got no continuity. I could have easily moved my multimeter lead from, let me get the lead out here, I could have moved it from this side of the switch over to here and then gone ahead and taken my reading, you know, here like this. Okay, I could have done it that way. But, you know, that entails going underneath, finding out which line goes where, and all this other stuff. And I found it's a lot easier. It's a lot easier. For those of you who may have never seen an on-off switch, I'm going to show you what's going on here. These two connections right here, this is a combination switch actually. The volume control is the front part. The on-off switch is the second part. These two connectors are on-off. The three connectors up here in the front, this is volume control. This is not volume control. This is on-off switch. So all I would have had to have done, if the switch had been frozen, you know, been rusted shut, been broken, or whatever the case may be, in order to get that reading through that primary coil, the quickest and easiest way is just take yourself a gator wire and jump those two right there. You don't have to search out wires or nothing. There it is, jumped. What that does is close that switch. I just jump across that switch. Okay? Essentially what I'm doing is that right there. Okay, don't be afraid to use your gator wires sometimes for you know, measurement purposes. I would have done this in a heartbeat had that thing not worked. Okay, that's it. Next time we start ripping and tearing on this. I think I caught up on everybody's comments. If I missed anybody, I'm sorry. I didn't mean to. I'll take a look at them again, but I think I got them all covered, unless there's some new ones that just came in. So until next time, when we really start to dismantle this thing, this is John. I appreciate you being here once again.